Question number 4's diagram is already set up for you right here, and I'll just read you through what the problem says and how I drew this diagram. So the problem says, a person standing on a cliff throws a stone with an initial horizontal velocity of 15 meters per second. And the stone hits the ground 47 meters from the base of the cliff. What that means is that they're giving us our x distance this time. All of the other problems we've done have given us the y distance and asked us to find x. This one's just reversed. It tells you it falls 47 meters from the base of the cliff. That's your x distance. And then it says, how far does the stone fall, or how high is the cliff? So you're finding dy, your y distance. Let's take this diagram and turn it into a chart. Starting off, I'm going to add in the things that are always true once again. For a horizontal, these are also always true. Now I'm going to add in what we know. We know that the initial x velocity was 15 meters per second. Therefore, the final is also 15 meters per second. We also know that our x distance is 47 meters. And we want to find the y distance, which will be negative. Okay, so this one is a little bit different, but a lot of the things are still going to be the same. If you look at the y side, which is what our variable that we want to find is on, it's on the y side, we only know two things. That's not going to be enough. All of our equations have 4 variables, therefore we need to know at least 3 of the variables plus our one unknown. So we're going to have to find something using x that will help us on y. The only thing that you can find on x that can really help you on y is time, because time will be the same for both x and y. So to start off, I'm going to use one of our equations to solve for the time using x. It appears as if we could really use any of them that involve time. The only one that doesn't include time is equation number 3. 1, 2, and 4 all include time, and we know all of the other variables. Now, this is almost true. However, the acceleration on the x side is 0 meters per second squared. That means that an equation like equation 1 won't work. We'll plug in the final, we'll plug in the initial 15 and 15, but here's the problem. When we put 0 in for the acceleration, it will cancel what we're looking for. So we need to use either equation 2 or equation 4. Either one will work just fine. I'm going to go ahead, just because we use it a lot anyways, and use equation number 2 for x. Now I'll plug everything in. So before, we'd only used equation 2 on the y side. Now that we're using it on x, we see that there's something that's different. This part of our equation that had canceled before no longer cancels. However, this part does. The acceleration is 0, therefore 1/2 at squared will all end up being 0. So we're left with 47 meters equals 15 meters per second times the time. All we have to do is divide by 15 to get time on its own. So the time that it takes is 3.13 seconds. Now that we have the time, I'll plug it back into my chart, which gives us enough information to solve for the y distance using the y variables. Looking back at our equations, we have to decide which one to use to solve for the y distance. We know that we need to include the y distance, but not the final velocity, because that's something that we don't have and we're not looking to find it right now. The only equation that does not include final velocity is once again equation number 2, so we're going to use equation number 2 for y to find the distance in the y direction.